All right, I know you're going to love these. Excuse me. Well, it's 10:17. Just got back from my basketball game. I'm sure you care, but we did win. In fact, Teach hit the game-winning three-pointer. That's the first in a lifetime. All right, well, anyway, we've already done this. This is on page 9, but I want to just kind of start here, our little journey that we're going on. Okay, so if you remember at the bottom there, page 9, make sure to turn there real quick. It said a chemical equilibrium position can be changed by applying a stress to either side of the chemical equation. Once the stress is relieved, a new equilibrium position is reached where the forward and reverse reactions are once again equal to each other. That's key. All right, the French chemist Henri Le Chatelier. Now, you'll watch a couple of videos maybe that say it different. It's French. I like Le Chatelier's, whatever. Anyway, he studied the changes in a system that result from changing the conditions of that system. All right, he proposed Le Chatelier's principle. If a stress is applied to a system in a dynamic equilibrium, the system changes to relieve the stress. Now, I know I sound immature, but the way I memorized that when I was a kid is that a system that is stressed will relieve itself. All right, now, I want to talk a little bit about what this is even saying. Let me change the pencil color just for fun. All right, you might remember, hopefully you do because it was yesterday, we graphed products, that's actually reactants there, I guess, versus our products. So this was our products, and here were our reactants. Our reactants decreased as the reaction progressed, and our products increased. Okay, what we're saying, let's say that we have A plus B going to AB. All right, so these are my reactants, and I'm going to products. All right, now if this graph were showing this over time, the reactants would represent A plus B, or A and B, I should say, and the products would represent just AB. Okay, so Le Chatelier is saying, change colors again, he's saying that if I apply a stress to this system, the equilibrium will change to relieve that stress. So I want you to think about it. Think if I have A and I increase the amount of A. All right, now if I increase A, the likelihood that A is going to run into B is more likely. So if that's more likely, then more B will be used up. So I'm going to remove B, and that would mean that I would increase the amount of AB present. Okay, so now I'm going to draw that with black on the graph. Now, don't stress too much if this graph is a little bit too complicated. But we said just a second ago that AB is going to increase. So I'll start still with the same low, but I will end higher. Now, the amount of reactants is tricky because one went up and the other went down. All right? So it will basically remain the same. Now, if this is the same, but this is more, I have a new equilibrium position. And that's not that big a deal. The rates are still the same now because I'm at equilibrium, but I have a different position of my equilibrium. I have the same amount of A plus B, roughly, but I have an increased amount of AB. All right, now this clip's about over. We'll pick this up more in just a second.